the resource showcase. This is the heart of the presentation here today. We're going to spotlight recent innovative resources that have been uploaded to the Ignition Exchange. And we're going to give a quick demonstration of each one of these. And don't forget that all of these resources that we're going to show are available for free today, right now. You can go and download and play around with it. So let's kick it off with Arnaud to talk about the DMC Siemens Open Library object and show us a quick demonstration there as well, Arnaud. So I'm going to make you presenter.
Thank you, Travis. Perfect. So let's start it with a little bit of a story of the library. So the library is actually one made by DMC, but we are using this library with a friend to make some projects in a fast way. And after a few weeks, we decided to search for a new HMI SCADA system, but still based on the same PLC function. So Ignition came as first choice, and the start of the development on Ignition was decided. And after a few days, the first release was made on the Ignition platform, Exchange platform, sorry. And we are now busy with the fourth release with some new feature. So I will show you how to download the actual first library, so the DMC one, to create your own project into the Siemens packet. And then show you how to create tags and how it's easy to create some view and link and how the tag is functioning and configurable. So to download the library, you can just Google it, Siemens Open Library, and you get the first link on the page of the library. You can download the latest version. So that's the part where DMC is involving, not me, but you know how to do it. It's also, the link is also in the Exchange description of the DMC Siemens Open Library. I have started with a fresh install of Ignition, and you can see I have a Siemens PLC connected of the new generation, so 1500. You can see it's connected. I will show you my DIA portal. Little bit of time to refresh it. So you can see I have a DB with multiple devices. Today I will concentrate it on the motor control device. So you can see we are busy with DB1 and with the start byte of 698. So this is very important for the configuration inside Ignition. Now I will show you inside Ignition how to create some tags. So you can see I have already, for the demo purpose, create an overview. So it's just a main screen, and I have also already import the DMC resource stuff of the Ignition. So it directly take it from the Ignition from the Exchange platform. There's nothing coming from my test server at home. So you can create easily a tag by searching the one that you need. So here I will take the HMI motor control. The library is working with one data type for the control and one data type for the error. You can see that it's easily recognizable by the start of the name. So we'll take the first the motor control, the HMI. I will give a name. So let's take motor 1. And then you have 3 parameters. So you have the DB number, the device name, which is actually the name that you give it to the device connection inside the Ignition gateway, and the start byte. So I will give it the needed info, and then just apply. So you see that the tag is created. I made the test here now with a new version of the Siemens PLC, but the library is also working with the old version, but my resource, I don't have it tested because I don't have an old version of the PLC. So, but according to DNC, it's the same structure between the two type of PLC. And I will show the feature that finished to convince my friend to use it ignition, and I think it's really cool. You just take the tag, drag and drop, and then you can check. You can just take the faceplate that you need. So I will take a pump horizontal, and inside the faceplate, you can see that the link to the data type is directly made it to the correct tag, and you have two of more. It's according to the faceplate that you are using. Here's two strings. So you have a tag name that will appear on the top of the pop-up that you will see this in a few seconds, and also the description of the motor. So we take motor 1, and I will put motor 1 reversing control. So, okay. I will save it, and then you can see I will take my runtime, just update it, and then you have it. Your faceplate with the pop-up directly linked. You can change modes, and you can also start stop in manual. So that's all explained into the manuals that you have with the download of the library. So that's it for my demonstration. So I spoke earlier about that we are busy with the 4 release. So there are 2 major features in the pipeline for the moment. For the 4th release, we hope to get the UPC UA server on board the PLC compatible, so to unlock the use of the optimized DB inside Siemens PLC. And for future release, we are now looking to switch the library into perspective. So actually, it's only the vision that you can use the library, and it's also an Allen Bradley preparation. It's only on paper, nothing done yet. So also I'm always open to new contributors who can add some new features, some new language also. So now the library is in 5 language, sorry, English, French, Dutch, Italian, and Spanish. And also just give sample feedback. So the new adding to the website will be very useful for us of the working in the library and the real world, because for me it's only simulation. I don't use it for the moment. The part of ignition, I don't use it for the moment in the real world. For last, I want to thank Mr. Gonzalez for his contribution to the library on the last release. So yeah, that's it. Back to you, Travis.
All right, well, thank you so much, Arnaud. Looking forward to the perspective ones as well. That's a really great resource you've got there, and all that work that you put into it. Thank you so much for contributing that to the exchange and making that available to the community. All right, next we're going to look at the greenhouse temperature control resource that's on the exchange, and for that we're going to hand it over to you, Matthias, to talk about it and give us a little demonstration of that one as well.
Thank you very much, Travis. So yeah, just to give you a quick demonstration of our resource and what problem it actually solves, then I went on to the Ignition Exchange here, where you can see this image of a small part of the greenhouse. And the problem we had was that the heating of the greenhouse during the night times, it could go below 0 degrees, so all the crops will start to freeze and all that. That's obviously not good. So the obvious solution was to just put up an electrical heater and have it running for all the time. And obviously that's not the perfect solution. So we decided to build this in Ignition instead. We decided to do this by doing it as a project for the whole team, where we got the opportunity to build it in perspective, where we could learn something about the perspective module and also about the MQTT modules. So that's our main purpose for this project. And then on the image here, you can see actually this little box beside the heater. We have a few components in there, which is all described here in the text underneath. But today I will just show the perspective app itself. So if we head over here, we have our main page here. We have thought about both the functionality of the solution, but also a bit of the design. We try to do that because it gives the user a better feeling of what they're actually using, and it's a good way of delivering something when it looks good as well. So here in the main page, we can see the current temperature in the greenhouse. We can see the status of the heater and what mode we are in. Then in the bottom here, we have the latest 6 hours of data. So how has the temperature developed over the last 6 hours? Then we have another page here where we can see something about the historical data. So we have a minimum temperature and a maximum temperature over the last day, and then we can choose a week or a month, depending on what scope we want to see it in. We also have the feature here in the bottom, as you can see, that we can turn around the phone, and then it will change over to a whole week of data, which you can show. So in that way, we use the things in the opportunities in perspective and on the phone, so we can actually change views depending on the orientation of the phone. So we think that is pretty cool, and it was new to us, so it was a good opportunity to use that in an actual project as well. Then if we go back here, we can go to the settings menu here, where we have the option to either control the heater in manual mode, so we can put it into manual mode. Now it's stopped, then I can start it, then the heater will simply just start to run, and we can go back here to the main page, and then once it updates, we should see that it's running. So now basically the heater is running, so you have the opportunity to control the heater manually. You can go back to the settings menu again. We can stop it, obviously, that's a good feature, but we can also put it into the auto mode. In auto mode, it will run after the start temperature and the stop temperature, so it will try to control the temperature in that way in the greenhouse. So if we have a start temperature, then that means that when the temperature goes below this temperature, then the heater will start, and once it goes above the stop temperature, it will stop again. So right now it's around 20 degrees. So if I put in here like 22 to make sure that it actually starts, then I hit the save settings. We can see it's saved here. We can go back to the home page, and then it will run for like a maximum of 30 seconds before it will update the temperature. So let's hope it will start in just a minute here, or 30 seconds. So, and while we're waiting for this, I can basically say that this was a very good project to get the feeling of how a perspective is working, and this was the very first project we actually did in perspective. So it was a great project for working on as a team and pitch in everybody. So that was a very good project. So here we could see that it was actually running, and then of course we can stop it again. So just by showing that here, so save settings here, and it should go off again. So basically that's our resource, and we decided to upload this at last year's ICC because we think it's a good way of contributing to this Ignition Exchange, and we think it's a good platform to get both inspired, and the things you have shown today is that you can actually request some other feedback or request some solutions. I think that's pretty cool. So thank you. Back to you, Travis.
Yeah, thank you so much for going through that, Matthias. It's also good to see projects like this perspective as people are learning it. The little tricks that you're doing with turning the phone and having it be the mobile responsive. Using those features and contribute that, it gives more people ideas of what they could do in their projects, right? And that's really one of the big goals of the exchange is to springboard ideas and show what people are doing and to use somebody's take this example and leverage it for your projects, right? And maybe you build something you think is really cool, contribute it back to the exchange, and we can keep that really going. And the projects that we're building are going to get better and better and better as we go forward. All right, let's go to the next one. And this is going to be over to you, Yen, to talk about the IFM sensor templates that I know interface with your actual sensors and make it really easy for Ignition and IFM to work together. So I'm going to make you presenter here and go ahead and explain and show your resource, please.
All right, sounds good. Perfect. So what I want to do before we get into the actual template stuff, it's probably best to describe, why did we even want to do this, right? So so in essence, IFM is part of a much larger organization that has developed a new sensor technology sensor communication technology that allows us to basically extract more information from your typical sensors here. And this page kind of just illustrates for us, what the difference is between a standard sensor that you employ today compared to one that has the IO link capability. Standard sensors today, there are microprocessors in there, but in a firmware, you have to dumb it down to give you an on and off signal, which is what this one on the left-hand side represents. But if you connect this via IO link using the same cable, and in this case, using the same exact sensor, this allows you to unlock a lot of information that you can present to other systems, to your PLCs, to Ignition that you can use. So this technology really allows us to bring smart data from our sensors, really untrapped data that exists on your sensors, and make it available to other systems to be able to use. And this whole entire technology revolves around the fact that this technology doesn't allow you to add cost to the system, because the cost of the sensor is the same whether it's an IO link or non-IO link version of it. And the architecture doesn't require re-engineering. You're going to be using the same exact architecture cabling system that you're used to using today. At the end of the day, you just have the ability to be able to get more information from your sensors. So that's part of the reason, number one reason why we decided to partner up with our friends at Ignition to develop some templates. We want to be able to talk to these other systems like Ignition very easily, because we have a lot more wealth of data to be able to provide. And this is the example. It's just to show the controls architecture. The sensors go into what we call an IO link master, which is really just, think about it as a smart Ethernet IO hub. Of course, we are able to pass this information to a PLC because, of course, you need the sensors to control your processes. You need the PLC. That's what the PLC does. In addition, the unique thing of what IFM does, we've added an IoT port here that simultaneously can allow us to send information that maybe are not time critical or not needed as part of the process to be sent to systems like Ignition. So now we have something what we call the Y path to allow us to, of course, send information that you want to control your machinery, but also now be able to send information that you might want to trend, monitor at a separate system. So basically bring data to where you want it to go. And since Ignition has been such a popular and growing SCADA system, we wanted to make it easy for our customers to be able to integrate our sensors, our IO link sensors, into that platform without any work, right? And that was the goal of this partnership with Ignition here. So just to show you how easy that is to do, I'm going to give you a little bit of a demo here. Here's my Ignition system. These faceplates that you see that you can download are a prospective template here. I've already import the files that I need, and that's really easy by itself. There's only 2 files you need to import. You need to import the prospective project into here that contains all of our sensors, and then you import another file here for the UDTs and stuff. So let's say in this case, in my demo here, I have an airflow meter of IFMs here. So to get to that, I just simply right-click. I'm going to create a new tag with a new data type and within the IFM folder. In this case, it's going to be our product line, the SD, which is our airflow monitoring sensors. I'm going to click on that. Next thing you need to do is give it a name. Let's call it airflow here. And then once you do that, there's only 2 parameters that you need to provide for this to get information. So I'm going to click on here. One is the host name, which is the IP address of our IoT port on that block that I showed you earlier. So we type that in a string format here. And the other thing that you need to put in is, okay, what port is that specific sensor connected to? In this case, it's on port 1. So I'm going to commit that, apply it, and hit OK. Now you have an airflow sensor, and you have all these specific UDTs, and you see the data coming in. So in this case, we're getting the flow data from this particular device. We're getting a pressure information from the device, temperature, and we're also getting a totalizer count here. You know, just having to use these is fantastic. This is such an easy way for us to get the information in the relative context that we're looking for, right? As you see, there's no scaling. All that stuff is done. With IO-Link, you're actually getting the true digital process value of the sensor. But then we took it up a notch here and decided to, all right, what if you don't want to do the extra work to do the visualization? Well, you know, what we've done here is you can now take this instance, drag it in. Now it's a little slow here, but let me see here.
Go ahead and just close that view and reopen it. It's a bug with multi-monitor, different resolutions.
Gotcha. Okay. So from here, you see we have a prefab template for you here that, again, brings in all that information from IO-Link of this airflow sensor. You get the vendor ID, device ID, serial number for traceability. You get the process values and temperature. We can reset the totalizer if we wanted to here if we go into the play mode. So that allows us to reset the totalizer all in one. And you see how easy it is to be able to implement any of these different IFM sensors. And as we move forward, we'll plan to increase the library with basically as much of the IFM sensors as possible within this library. So thank you very much.
Yeah, and there was a quick question, which is, what is a totalizer? You want to quickly answer that question?
Yes, absolutely. So the totalizer is measuring the amount of air that's passed through the pipe, right? So that's good to kind of, if you're looking for energy monitoring, you want to know how much have you used already of air, or in some cases flow, a fluid of some form.
Perfect. Well, so thank you so much for that, Yen. I mean, that's an amazing resource here. And then this is, again, the power, right? The community at large, we want to make things easy and make the stuff that nobody wants to think about. Just make it automatic, make it quick, drag and drop and go. And we can start focusing on the bigger and bigger, bigger features, bigger and better things we want to do with our applications and providing more value to the customer at the end of the day. And I think this is really going to do that for us.